All right, welcome everyone to today's Ackuretta webinar from Scan to 3D Prints and Introduction to Digital Workflows. And it's presented by Dr. Shiva Shankar and supported by exocad and Dental Ceramists. My name is Julia and I will be your host today. So let's get right into it. It's always a great honor to host these events because I get to speak to some of the brightest dentists and technicians around the globe. And I'd like to introduce today's speakers. Let's give a warm welcome to Dr. Meghana, a prosthodontist by trade, and she's now working as a sales representative at exocad. As a passionate dentist, Dr. Meghana worked as an assistant professor at the GDC Mumbai, as well as a product manager at CEREC. And today she's here to share her passion for digital workflows with us. So thank you for joining, Dr. Meghana. Our main speaker today is none other than Dr. Shiva Shankar, and it's always a great pleasure to listen to his presentations. Dr. Shiva brings a wealth of experience and knowledge to the digital world and is known as India's pioneer in digital dentistry. As the director of Confident Dental Lab and as a professor for digital workflows, Dr. Shiva has been sharing his knowledge for years, and we're thrilled to have him here as an exocad licensed exocad trainer and also an avid Ackuretta user. So we're really looking forward to his lecture on how he's integrating these workflows in his daily office. He's giving us a wave here, so hi Dr. Shiva. And last but not least, we have Manish Jain here, the technical director at Dental Ceramists, and he's led Dental Ceramists for over 22 years, and he's a seasoned entrepreneur with an acute interest for digital dentistry. He's also a certified trainer for such brands as exocad, Medit, 3M Lava, and many more. Dental Ceramists is really known for bringing the CAD/CAM dentistry revolution to India. And they had the first milling machine actually in 2008 and the first metal printer in 2010. So we're really excited to listen to Manish and hear about his knowledge in this field as well. Let me give a brief overview of what we're going to do today. We're going to start with a presentation by Dr. Meghana from exocad, and she'll give us a bit of an insight in what you can actually achieve with exocad. Then we have Dr. Shiva, who will be sharing his hands-on experience with everything, with the equipment and exocad, and what you can actually, do in your own workflows once you've adopted this workflow. And then we also will hear from Manish about Dental Ceramists and their expertise. And then lastly, we will have about 15 minutes for a Q&A session. So please send in your questions in the questions tab that you can see here at the bottom of your screen. On the right side, you should see that. Be sure to drop it there and we'll bring it up later. Throughout the sessions, we will also be answering some of your questions. Then before we start today with an introduction, I would like you to know that we're also going to be hosting a workshop soon together with Dental Ceramists and with exocad. So let me show you that right here. It's on November 26th. Dr. Shiva has gracefully accepted to be our lecturer for this event, so we're quite excited. And it's going to be at the Dental Ceramists training facility in Mumbai. So be sure to register. I will drop a link in the chat right now so you can check it out. And yeah, without much further ado, I would love to introduce Dr. Meghana again and say hello and thank you for being here. We're really looking forward to learning from you. All right.
Thanks a lot, Julie. And namaste to all of y'all. It is indeed a very, very big pleasure for me to be a part of this webinar, where I have some of the most experienced people in digital dentistry, right from Dr. Shiva and from Manish Ji, people whom the entire industry really looks up to when it comes to digital dentistry here. So thank you once again for being a part of this webinar for us. Very exciting times for 3D printing, very exciting times for digital dentistry in India. And I'm glad and I'm very happy to see the direction in which the country is moving forward when it comes to digital workflows. Let me just take you through a little bit about exocad and what exactly do we do. So a super short disclaimer. This presentation is just for this webinar, and please do not share it or take screenshots and circulate it elsewhere. A little bit about us. So basically, exocad initially was a part of a research institute called as the Fraunhofer Institute in Germany. And we have been working on dental CAD related research since 1989. In 2009, the first dental CAD product was launched. And in 2010, exocad was founded. We have a headquarters in Darmstadt, which is near Frankfurt, and we have about 5 offices globally with more than 220 employees. And a very interesting fact is that about 180 or more people are involved in research and development. So that is how much effort exocad invests in keeping up with times, trying to make sure that the latest technology and solutions are always available to you. We have 3 basic products. First is the dental CAD software, which is the software which most of our laboratory use for designing everything from crowns and bridges to full dentures, partial dentures, and implant prosthesis. So we have about 15 modules that a lab could use. And it is one of the most robust softwares that we have currently. We also recently came out with the chairside CAD software. Now, this is a software which is customized for dentists to use in their clinics. And it is a very simplified workflow. With a few clicks, you can go ahead and design a full restoration. And the third software we have is called as ExoPlan. This is a software which is used for planning the implant placement and designing surgical guides. Now, how do you know which software is really right for you? A very interesting website, I would like to take you there. So when you go to exocad.com and you go to the CAD configurator, you can see that you have this option of trying out your configurator. So this is somewhere you could actually check. You could check which area you are based out of. You could select what is your design indication. And when you fill in your contact details, you would get a recommendation from us and a list of resellers from where you can purchase the software from. You could also log into the exocad web shop once you have purchased the license, wherein you could contact your reseller and exocad to purchase additional modules online. Now, how do you purchase the exocad software? Again, I would like you to take you all through our website. We have a link over here wherein you could go ahead. And for India, for example, you could select which country. So let me check if we could go ahead and select India. And here you have a list of all resellers who sell the software, the legal authorized software in India. So you could choose to contact any of our local resellers and purchase your software. I can't stress how important it is for you to purchase an original software. Please do not get into the trap of purchasing a software which is not licensed, and do not put yourself and your business at risk. Please contact one of our official resellers. Everyone is more than happy to help you, to support you. And the benefit of having an original license is that you are using a software, and you are using a software to treat the patients. So using something where the patient's data and the legality of the software is important is of extreme importance. So this is something that I can't stress enough. And I'm really proud to say that India has one of the largest number of resellers. So please feel free to contact us at any given point of time for any sort of support. More or less, this is all I have from my end. And thank you for listening to me patiently. Over to you, Julia.
Thank you, Dr. Meghana. Yeah, thank you for that overview. And we will see Dr. Meghana again later for our Q&A session. So if you have any questions for her, please feel free to put it in the questions tab. Dr. Meghana is really very experienced with digital workflows as on CEREC, also on exocad. So yeah, be sure to check it out later. And now we're handing it over to Dr. Shiva, the pioneer of digital dentistry himself. So here we go, Dr. Shiva. We're looking forward to your presentation.
Yeah, thank you, Julia. Good afternoon, everyone. Good evening. It's a pleasure again to see you all, to share a little bit of information from our side. I think I will start my presentation without much of the ado. Today we're talking about, today I'm sort of introducing you to the digital workflow, and seeing by the list of participants, there's a lot of people who are already using it, who's a little in the startup stage and things like that. Today I'm just giving you an overview of the workflows, what we can have in digital dentistry, or how we can forward, and how we can go forward, and how we can establish this into our practices or into our laboratories and things like that. So digital dentistry is no longer just a buzzword. You know what, digital dentistry or digitization of my clinic or digitization of the laboratory is no longer a buzzword. It is here to stay, and there is a lot of research now which says that digitization of dental care workflows have proved to provide quantifiable benefits in terms of quality, time savings, labor cost reductions. It's already been very proven, and there is a lot of research papers which have been published already in the peer-reviewed journals that it is really helping us to achieve the quality, the time saving, and the labor cost reduction. Now, what are the benefits of digital technologies, or why should we get into the digital technology part of it, or why should we start embracing this into our day-to-day practice? I think I would summarize these in the benefits column as these four notations which I have told. Is one is communication and visualization, improved quality. When I saw about improved quality, it is the precision and predictability of the restorations what we give it, and also the quality of the restoration what we give to the patient is far more superior compared to the manual way. I'm in no way demeaning the manual workflow we've been using for hundreds of years, but we need some side of precision and predictability when it comes to the digital technologies. Of course, the third one is the archiving of data, and the fourth one is enhanced patient experience, because all of us are here or all of us practice for the patients, and once the patients are happy, we are happy. I would always say in my presentation that patient is happy, your pocket is happy. The patient is not happy, your pocket is not going to be happy. So that is the way digital technology works for us and how we can incorporate this into our dental practice. Now let us jump into what is this digital workflow. When we talk about digitization, when we have the analog dentistry, we have a workflow. A restorative workflow is typically impression, crown after the crown preparation and impression, pouring of the model, doing die cutting, ditching, wax pattern, investing, casting, finishing, polishing, and then delivering it to the patient. But when we look into the digital workflow, all these, 12 to 15 steps, what we discuss in our manual workflow gets accumulated into these three steps. And these three steps basically are acquisition, the impression stage, then you have the designing, then you have the production. So once I get the impression, when we talk about impressions, we talk about the digitization. Digitization or acquisition of data can be acquired digital. If you want to do a digital data, we can acquire it in two ways. One is a direct acquisition, that is the intraoral scanner, which is becoming more and more popular in Indian subcontinent for the last year or so. And then, of course, we have been using this for, as Julia introduced Manish, or we as in our laboratory and all, way back in 2008, 2009, we've been incorporated all these technologies into our laboratory. And I would say that in India, dental laboratories are more digitized than the clinical sector. So this is the way we have all been doing crowns and bridges, wherein we send the impression, that the dental technician pours a model, then digitizes it, and then he clears it, and then he does the CAD part of it. Let us look at into the intraoral scanning. Here you can see a representation of the intraoral scanning of it. You can see that it is a direct acquisition. It is immediately, you can visualize it. And today with intraoral scanning technology available, there are a lot of benefits out of it. It is not only the visualization of it, it is also the analysis of the restoration we do. See, all of us know when we're doing impressions, we send a model, then all of us have gone through this at least once in our lifetime, that our dental technician calls the next day and tells, sir, the clearance is a little less on the lingual cusp, or something is not happening in a proper way, or the impression is not good, and then we need to redo the impression. Whereas with digital impression, the biggest advantage I feel is that we are visualizing everything at that instant. If there is any flaw in our preparation, if there is any flaw in our way we have taken our impression, we can immediately delete it and we can do it again. So this is what is the greatest advantage as far as me is concerned. And the second thing is your communication becomes much faster with the dental technician. If you want, the patient is still in your chair, you can send it across. You can do all restorative analysis inside the software itself, or you can just send it across to your dental laboratory and then send a message, and then he looks at the data and he gets back to you, so that you're not losing your precious time and the patient's precious time into it. You can see another case where we have done a digital impression here. We scan it and you can see the preparation margins. You can see the margins which is there. You can visualize everything. You can also activate the restorative analysis. You tell the software that you're going to do a zirconia restoration and you require 1.5 millimeters of clearance to it. You just have to enter the data into the software, and the software will give you a color map which says that if there's a clearance is good or clearance is not good, you can rotate it 365 degrees and you can check it. So you are having a correct picture before you send it to your lab technician, so that there is no question of repeats or things like that. So once this digital impression is recorded, the next step what we do is going to design a crown, whether it's a clinical crown or it's a laboratory crown. Today there are many softwares for softwares inside the intraoral scanner where you can do an immediate temporary restorations, or always, as Dr. Meghna said, we in exocad we have a different portfolios for different concepts of what we work with. So we use a software. So what I will do is I'll just take you around to work on the software. So I've already imported this. So you can see that you can see my screen, right? Julia, you can see my screen?
Yes, perfectly.
Yeah. So this is a digital impression which I showed you there. So let us look into it. See, this is the advantage of having a digital impression, so that I can rotate it 365 degrees and I can see it every angle what I want. And then without much, this one, what the first thing the software asks you for doing is recording the margins. So what we do is we just visualize the margins here, and we have a, you know what, if we are, the advantage of an intraoral scanner and we are looking at an image which is a PLY or an OBJ image, is that I can visualize, see the, because I can make a demarcation between a pink and the tooth color. Or if I say that, okay, I am not, I want to look into it a little bit of contrasting things, I can look into this. See this. This is a tool which I can activate called as a True Smile, and then you can do it, and I can look at it, and it gives me a fair idea of where my margins are, and I can click on these margins. So I can do it here. So you can see this. This is there, and once I draw my margins, I say next. So now what happens is, it is like your traditional workflow. What we do is, our dental technician, once he does the design, he once he ducts the die cutting and ditching, what he does is he puts a cement spacer. You can have everything under your control here. You can see that the green area is the area which shows that there is no cement gap, and then the golden area is the area where there's cement gap. So based on your own milling machine, the sensitivity of the machine, the sensitivity of the printer, everything, I can adjust this. We have everything in our control, and we can see all these things here. So you know what, it is very easy for us to look into it. And then I say next. Then you say that, you know what, then you know what, the software will give me a proposal, which gives me a proposal saying that which is my tooth. It recognizes which is my basic buccal to buccal area, lingual area, and then you have a give a tooth. Now, when you're looking at exocad, we have different libraries. You know what, you don't like the anatomy of it, you can just go here and say, okay, I need an anatomy which is going to be a little smoother anatomy. You have a different libraries, and you can also purchase libraries. There are a lot of libraries available in the market. You can purchase it, or even in exocad, you can go to the exocad website and purchase a few libraries which are available, like ZRS libraries and things like that. Nevertheless, with the basic software or with the software, you will have around 10 libraries which are already pre-fed libraries which are there inside your software, which is part of it. So you can look at it. Now I have got a basic proposal of it. Now I can start working on this proposal to see how it is going to work. So here I can work with, I want to scale it. I can do the scaling part of it. I want a little longer one, or I want to do it. And you can see that it shows the high points also shows there. That is, there is going to be this one coming into it. You can look into all these things, and then I say next. And then now it gets adapted to our margins. And when you see the margins, I can see that you know what, I can work with the margins in all these workflows. That I don't want to use this, I can use the different tools to, for example, I want this ridge to be a little less. I want this cusp to be a little more prominent. If I want this cusp to be prominent, I just go click on the cusp, and then I can bring it. So you have tools which are very, very easy to work with, and which you can work on that. And added to it, you can also add a virtual articulator to it, so that in all lateral interferences, you can remove the interferences in the lateral area, so you can get into it. Now, when I look into it and I say, okay, you can see that there are some high points here, or the interferences there, and it shows here the interferences based on the color chart. So what I do is I just say cut intersections, and all my intersections are removed. Then I can start working on it. I can say I can smoothen it a little bit. I have different brushes to work on it. So you can see that I have a tool which I can smoothen it. Or I want to add some contacts, I can add some, this one. I can also look into my, activate the contacts here. And I can remove the jaw scan here, and you can see that where my contact is. Now I can move my contact, whether to the mesial contact or the distal contact. I want a point contact, I want a broad contact. Everything can be controlled by us as a operator, so that you are always under control on your workflow. Then once I'm happy with my workflow, I say next. And now my crown is ready for the milling. You can see just with the 4 clicks, your crown is ready for you to do it. So now you can see the margin so well it is there. You can see that the margin is here. And you can also, if you see that this is where my cement spacer is there, and from here there is a cement spacer. You can see this. This is so prominent that you can see that this is no cement spacer here, and from there's going to be a cement spacer here. You can control everything which you want into it. And then if you're going to mill it, you can mill it, or you can go into, if you want to design a model, you can go further. You can see that it is a design model. You can take it across, and then you can work on it. So let me come back into this after I finish my a little bit more. I will take you across the cam, and then we will come back again to our workflow here. So you've seen that how it is, how easy to work on a single crown or a bridge, and based on it you can do on this. Now presently, once I finish the CAD, now the third part of our digital workflow is the CAM. The CAM is the way we produce the restoration. So restorations are to be produced. We generally in dentistry we have two methods of production. One is the subtractive manufacturing or the milling, which is the age-old technique, which been, you know what, all of you must have at least seen in the photographs, a milling machine where you put a block and it rocks out of it. But only small disadvantage with the milling is that there is a loss of material which is there. So now with the advent of additive manufacturing or 3D printing into the world of engineering, dentistry has become, you know what, dentistry is now the number one business for all the 3D printing companies, whether it is a small company or a big company. So that is the, you know what, dentistry is tailor made for 3D printing or additive manufacturing, because we typically produce very small parts and we only produce one part. We are not a production house where we want the same part to be done for 100 times. So that is why additive manufacturing or 3D printing is been you know what, is been tailor made for dentistry. Now, what is this 3D printing or what is additive manufacturing? 3D printing is a process for making a physical object from a three-dimensional digital model. That is your CAD design, which you come, the STL, what we imported to it. That is a three-dimensional digital model. And what we do is typically how does additive manufacturing work is, additive manufacturing works by laying down many successive thin layers of the material. In dentistry, if you look into it, I can say, let us go back to our student days. We've all been coming to our basic BDS level, whether it's a first year or second year. We were all made to carve a tooth out of it, where what we did was we took a wax block and we started carving it out. So that is typical of a milling. But when we came to our clinical science, we started doing composite restorations. When we did composite restorations, we always do composite restorations in layer by layer. Of course, there are some materials today like bulk fills and things like that. But if you want stratification to be done, anterior aesthetics to be done today, even today, we follow a technique of doing layering by layering. So this is a typical example of how 3D printing works. Now let us go a little bit more about 3D printing part of it. Now when you're looking at 3D printing technology, there are many technologies which are presently available in 3D printing market in the general industry. But what is caught the imagination of dentistry in 3D printing is these three concepts which you talk about: stereolithography, the liquid crystal display technology, or the DLP technology. So these are the three most, I would not say that it's the only technology. There are other technologies which we use for 3D printing. But in dentistry, because we look at chair side or we typically look at small parts, a crown is just a 5 by 5 or a 10 by 10 millimeters of a crown is what we took, or 12 millimeters is what we look. So we do not require huge products for our 3D printing. So we are looking at it. So there are advantages and disadvantages of all these type of things. Here you can see that I don't want to go deeper into it, but you can see the matter which is there into this part of 3D printing which is there. So what are all things we can do in digital dentistry today, or 3D printing? What can we do with 3D printing? With 3D printing, typically you can do anything which you think about it. You think about digital models, you're talking about surgical guides, you're talking about temporary crowns, denture bases, denture teeth, removable partial dentures, trays, gingiva, splints, mouth guards, castable crowns, implant prostheses, indirect bracket trays. And as I am speaking, we can also today, we have materials available in the market which are FDA approved materials for permanent restorations, where there is some ceramic fillers into the material. We have denture bases which are a little bit flexible. I don't say it's totally flexible, but there are materials which are available, flexible materials which are available. So you have an entire gamut of resin chemistry, the entire gamut of restorative protocols which we can work with to do a lot of prosthesis, which part of it. Now you can see, whenever we think about a 3D printing is not just about a printing of a particular product. If we need consistency, when I talked about predictability and precision and predictability, there should be a workflow to it. You know what? You cannot just take one 3D printer, buy some 3D printer, put a crown, and then do it. It is not an engineering science, because in engineering science, what happens is they print a product, and that is why it is typically called in engineering science as a prototype. In prototype, what do? We just take a part, and then we can, we can sandpaper it, polish it, paint it, and then see the product, because the dimensions of my product is not a very important criterion when I'm doing my prototypes in engineering science. Whereas in dentistry, we are dealing with crowns, bridges, we're talking about surgical guides, we're talking about temporary crowns, we're talking about splints. We want these crowns or the bridges, what we have printed, to precisely fit in the patient's mouth. That is the most important. So if you want the predictability in your workflow, you need to find a solution for it. And the solution is not from, it starts from developing a file to be 3D printed, the 3D printer, and the post-processing of the 3D printing. So let me talk about the process, how we go about with it. Now, when you look at this solution of Ackuretta, what we are talking about, a 3D printing solution, they are like, what I would say, a turnkey people. They have, revolutionized the way we think about 3D printing, because I personally know the owner of the CEO of Ackuretta. He is a good friend of mine, Mr. Aish Bagla, and it's a good story that Aish Bagla, through one of my friends' contacts, came to my laboratory and said, "Doctor, I'm Aish Bagla and I'm looking into it." And from that day onwards, he's, I've been following him, and we've been in touch for so many years. Even though he's relocated to Taiwan, we've been in touch, and he's a wonderful guy, and he's really motivated to bring dentistry to the next level in 3D printing. So he's developed a solution, and he's constantly looking into a solution. And probably one of the few printers in the whole world, or I could say only one printer in the whole world company, where they're trying to activate the resins. They're trying to make the user bring in all the resin profiles into their portfolio, so that the user is not inconvenienced of doing anything. So it is effortless 3D printing is what they talk about. So in effortless 3D printing, they have an intuitive slicing software called as an Alpha 3D. They have a printer which is great printer, a Sol or a Dentic. They have two ranges of a printer called Sol or Dentic. Sol and Dentic can be remotely accessed by them. Their their support system is so good that they have everything, and they have all the protocols which has to be followed. So coming to the Sol printer, it's a plug and play printer. It's an advanced monochrome technologies and things like that, blah blah, all these printers technologies which are there. But it's, at the end of the day, a very great printer, and for the last 2 years I've been using it personally in my office. Dentic is another printer which is also there, but it's a little economical printer because they have an RGB technology, or there is a different technology which they use. Whereas the Sol is a printer which they have been tuning every day to bring faster and faster prints to the end user part of it. Now you can see this. This is the difference between monochrome and LCD RGB. I don't want to go deeper into it. The main difference, what I see, is that it is a faster printer. A monochrome LCD printer is a faster printer, whereas an LCD RGB printer is a slower printer. It's open, automatic cloud-based, firmware updates, everything can be done on this. So you have a great product in Sol. Now, what makes Sol different, or what makes Ackuretta printers different from another printer which are available in the market? See, the other printers which are available in the market, the light which is they're using. See, everything depends on the power of light. All of us know that we are all composite resin users. We know that how important is the intensity of the light, and we also have an intensity checker. Most of us have an intensity checker. We check our intensity of the light, because we all know that depending on the intensity of the light is where the depth of the curing and the finish of the restoration comes in. The same way, when we talk about 3D printing, the light engine is a very heart of it. So if you see Ackuretta technology, they use a technology called as dynamic optical engine. So it recalibrates, or it calibrates itself to give the maximum power depending on the part. There is an AI which is included into it, which will break down the parts, and it tells you where it has to. It automatically gives the command to the machine where it has to give maximum power, where it has to give a minimum power. Whereas the other printers will give you a LED lens, which is a uniform power on all the areas, and thereby, as the time goes by, the light power comes down. Plus, what happens is that the power of the LED light, what they use, also matters when you're talking about the printers. Now, when you look at the performance of Sol, it is, you can see that an average print time for a dental model is talking about 50 minutes. When I talk about average rate of 50 minutes, it depends. The time what we have told here is just a representative of the time here. It may be fast, it may be slow, depending on what resolution of printing do we want. So you can see that it can be done, a liter of resin of Ackuretta dental model, you can do it, and the cost of the print will come to around 125 to 130 rupees. So you can look into surgical guides, temporary crowns, denture bases, teeth, and everything which is there. You can look into it, and then temporary crowns, they have come out with faster algorithms now. Within 20 minutes, you can get a temporary crown or a bridge into it. And mind you, when I'm talking about a particular part, we are only calculated a single part. If I put another part or another part, if for example I have five temporary crowns onto it, still the time taken for me to print is going to be the same when I'm going to time taking to print for me to a single crown. So today you have materials which are FDA approved materials which are available, and as I told you, there are materials which are with ceramic fillers which can be used for a permanent restoration or a long-term temporary restorations which can be done. Now if you see the comparable with Dentique, the only difference is that Dentique takes a longer time for printing compared to your Sol. Otherwise, the printer, the platform, the indications, everything is the same which you can do on it. Now here you can look at it, this resin, this material which I have put here is a material from Bego. This is one of the first materials to have got approved for FDA and permanent use. And you can see the finish. I have not put any glaze. I have not put anything here. It is just hand polished. We just print it and then done a hand polish, and then you can see the finish on the restoration part of it. So this is what a print can be done with temporites, immediate temporaries, and probably this is going to take you 30 minutes on chair side if you have a printer like Sol. The next application I would say which we are gaining to is your splints. Splints also, exocad has got a wonderful module for splints which is very easy. With just a few clicks you get the splints, and you can see that it takes hardly around 45 to 50 minutes to print the splint in clear material. There are special materials which are got a lot of resistance into it, which is there. So you can see that you can print it and then you can put it in the patient's mouth, and you can see how cool the patient's mouth is there, and it is just a few polishing away to get the polishes. Of course, surgical guides are a day-to-day part of it, and you can see exocad has got a wonderful platform called as exoplan and exoguide, where you can not only plan your surgical guides, we can also plan seamlessly our prosthetics, where I can do an immediate temporaries, a same day temporaries, or I can do a full mouth rehabilitation with temporaries, immediate temporization, everything. We can keep it ready even before we do the surgery. So this is what exoplan can do, and bundled with Ackuretta, we can deliver the results at much precise way. You can see a particular case which we have done. You can do a full digital workflow working on it. And of course, now the fancy of it is the digital is about digital complete dentures. Here you can see a case of digital complete dentures done by me in our laboratory, where we can use where we have printed the denture bases and the teeth separately and glued it. And you can see that today materials are available which takes up a good polish. There was once upon a time, maybe 6 months, 1 year back, the materials which are available were not taking up such a polish. But today, with a normal ordinary polish, you do not have to take any other extensive way. You can still polish it. Or you can also do for trial a monolithic dentures, and you can do it. And exocad has got again a module called as removables, where you can do complete dentures very seamlessly. Maybe a half an hour's time, you can design a complete denture and finish the case part of it. Now, as I told you, Ackuretta as a company or Sol is a product which is being upgraded constantly. Now they have done their own R&D and they have come out with different platforms. You can, they have 3 different platforms. One bigger platform, or the regular platform, where if you want to print models, 2 or 3 models, you can pour into it. Or if you have only one model to print, you don't have to use the bigger part. You can use a small platform, the build, it's called as the medium build platform, which, it hardly takes around less than a half an hour to work with to get a print out of it. And you can see a smaller platform they have come out again for crowns and bridges, especially for crowns and bridges, because in private practices, we are not going to print 20 crowns. We're just going to print 1 crown or a 3-unit bridge or a 4-unit bridge, and it takes around 15 to 20 minutes to generate a crown and a bridge. It's so fast, the patient is sitting outside and you can, you've already seen a couple of clicks, which just takes a minute and a half to make a temporary or make a design inside your exocad, and then within 30 minutes you can finish it off. A scan takes a couple of minutes, or you know what, you're doing a single crown, it hardly takes less than a minute. Another 1.5 minutes to design your crown, another 15-20 minutes to print it, another 5-10 minutes for you to do the post processing. I think within half an hour we have a great workflow to finish your temporary crowns or temporary crowns and bridges onto it. Now, you know what? The base of all these things is, once I get the CAD design, is that we need the whole thing works on how good I slice my how good my slice my software, the crowns, and then art is where. So what I'm going to do is, Ackuretta solves Alpha 3D is directly integrated into exocad. You do not have to open another software to work on it. You can see this. I will take you across. Once you have here, you can see that if you are, and you do not have to do any linking. If you already have an Ackuretta solve the Alpha 3D software into it, the moment you open your exocad, it automatically detects Ackuretta Alpha 3D is there, and then you click on it. And once you finish the design, like what I did, you just click on the Ackuretta Alpha 3D icon, and then the Ackuretta 3D software opens up. And then it is already selected. See, it says that please select the material for Alpha 3D. It is crown 1.5. And then I say proceed to printing. Once I say proceed to printing, Alpha 3D software starts. And this is a regular platform. What I'm seeing here, what you're seeing here is a regular platform of this. So we can choose our platforms here. Just a second, it's loading. So you can see this. You can see this. This is the platform which is there, and this is the platform which is going to be there. If you want, you can change the platform which is there. There's a printer. You talk about printer. You talk about the resin manufacturer. See, as I told you, they have pre-validated resins of so many companies here. You can see that whether it is Ackuretta or Argen, Bego, Dentka, Hars, NextDent 3D, PacDent, all these companies' resins are pre-done. You just have to select, okay, I'm using an Ackuretta, and what material I'm going to use. You're going to use a A2 or an A3 or a pore splint. You can do it A3. And then you can also say what is the surface finish. And I say for a temporary crown, standard finish is more than enough for it. And standard is around 70 microns is the 100 microns is the layer thickness here. You can see here what are all the brands which are available, what are all the things you can do it, and you say apply, and then you can look into it. Now your crown is ready for the this one. Then once I do it, now we need to generate a support, because we have to support the support, and you can do it. We can do an auto support if you want. You can just press on the crown and it does. Or I say that I will select what is the thing here, and I can press on crown here, or I go to auto supports. They've already made a pre-supports for a bridge, a crown, and a splint, and then I can work on this, and I say okay. The supports are, you can see the supports are here, and once I have done with the supports, I can see that you can see that the resin volume is going to take around 0.1 ml is what is there. The layer is 106, and you can see that if I can change the pattern here, it takes auto support takes here, and then I go to slice, and I can say okay, what is the slice which I'm looking into it, how do I slice it, and then you can see that it also gives me a detail that if I'm doing, you can change it. See, if I go to the finest, which is going to the finest, it's going to take 211 layers. If I'm going to the fine, it is going to take 151 layers, and if it is going to be standard, it is going to be 106 layers, and they also have a fast one which is around 71 layers. So what does this layers of number of layers indicate is that the lesser the number of layers, the faster the print is. So once it is done, I can put it across, and I can create it, and I can say save and slice it, it'll slice it, and then once I slice it, it automatically, and then I can share it, because the printer is connected via Wi-Fi network, or you can also do a LAN network, and I can connect, if you are through Wi-Fi network, you can connect it from your desktop screen. You just have to open your Google Chrome processor, go to the printer and look at the IP address of the printer, and you type the IP address, and you can connect it, and you can control the printer. You can sit at your place and check what the printing is going on. You can also have options of remote printing into this. So there are a lot of options which are intuitive options into this. This is what is the Alpha 3D printer works with. So let us get back to our presentation now. So I will just go back to my presentation here. So you have an Alpha 3D printer. Once the printing is done, you load it to a printer. Printer takes time. You load the print into it. The post processing, as I told you, is more important. So what you have to do is you have to do you have to clean it. and you clean it normally with ultrasonic cleaners or the wash station. They have a cleany wash station where you have two jars. One jar is for your initial print, what you do it, and then you can take a fresh IPA and then do it. And this cleaning is done by IPA, and the purpose of this cleaning is to remove the uncured resin, because when there it is dipping into the resin and the resin is getting cured, there are a lot of uncured resins which are there. If, for example, if I cure it again like that, what is going to happen is that these curing resin is going to come in the way, whether the crown is going to high point or it's not going to fit properly. So we need to properly wash out all the excess uncured resins, and once it is washed, then we dry it out, and then we put into a UV box. And UV box plays a major role in the curing of it, because if optimal cure has to be done, you have to use a specific curing bath to it. Like this is a simple curing one which they use a mirror reflection, they call it a UV box, and this is mainly suitable for their class 1 materials like models and things like that. But if you really want your material to be FDA approved, if you read the manuals of all these companies, they are only FDA approved provided they have been cured in a specific curing oven. So specific curing oven like Curie, which has got a wavelength of 385 to 400 nanometers, and they are compatible, biocompatible curing unit, because it is a complete cure which is occurring into it. So now you've looked into the entire workflow of it, and why should I digitize my office, or why should you digitize your office? I'm sure I've given you all the answers to it in a simpler way. Of course, you need to you want to know much more about it. You are welcome to join us on 26th November, where I will be present in Mumbai at the Dental Ceramists office. So we can go through the entire workflow, not only for crown and bridge. We can look into a lot more workflows which we can do into it. So now, why should I digitize my office or your office? Is because I feel there is a faster return on investment. Your time is the most serving, and you produce accurate applications in your house. You provide the premium same day dental care, and you reduce the chair time by almost 70-80%. These are the plus points when you're looking into getting into this workflow of scan, design, and print. So my dear friends, thank you. Within a short given time, what I could do it, I just gave you an overview of it. Of course, you're welcome, and then you can always type if you have any specific questions, you know how to get in touch with me. Just send an email or shoot a mail to Ackuretta, and we'll be glad to help you out. Thank you once again for a pleasant evening, and also thank you for logging in and seeing in big numbers. Thank you so much. Julia, it's yours.
Thank you. Thank you so much. That was a great overview. I think there was a lot to be learned. We did get some questions in, so we're excited to address those. I just want to point out again that we do have the workshop coming up on November 26th. So if you'd like to sign up, I just shared the registration form in the chat. So check that out, and then you will have the opportunity to put your hands on exocad, and you'll be able to really learn in depth what Dr. Shiva was just talking about. So thank you so much, Dr. Shiva, for being here for this presentation, and then also for coming in next month. So we're really excited for that. Now let me hand it over to Manish from Dental Ceramists. We're super excited to have him here because his team really is bringing all the experience to the table. And then guys, please be sure to stay for the Q&A session, which is going to follow right after. All right, Manish, the floor is yours. Thank you for joining.
Thank you very much, Julia, for the kind introduction, and Dr. Meghna for your insights into the exocad process of identifying the software suitable for everyone's needs, and also for highlighting the authentic software part, which is also important. And thank you very much, Dr. Shiva. Always a pleasure to hear you and see your presentation, and learn from you always. So Julia has already told about me, and I am a dental technician, being running a lab since 22 years. Have about 14 plus years of CAD/CAM experience, and we have been doing digital dentistry for, I would say, donkey's years, for a long time. And yeah, there are a lot of things that have changed from the time we had our first 3D printer to the Ackuretta printers that are the tiny, small tabletop, fast and accurate. So I can summarize in these 3 words. These are like, we had those giant printers which used to stand on the floor, and they used to take a lot of time to even print out the copings. So initially we used to only print out copings, wax copings for castings. So it has come a long way from there. And yes, looking forward to seeing everyone on the 26th. Julia, can we have that slide there? Yes. So on the 26th, we will have Dr. Shiva again here in Mumbai for a hands-on demonstration, and you can actually learn from the master himself. There were some questions over there. I think Julia will take care of them, and Dr. Shiva, and we will try to answer them as much as possible. And anything is there, Dental Ceramist, we are here. We are open for any questions. For not necessary you need to purchase from us. We are a training center also. We have our own academy also. You can ask us questions. We have our, I'll post the email ID where you can send your questions also. And we will be happy to help on any of the topics on scanning, designing, printing, anything. Thank you very much, everyone. And over to you, Julia.
All right. Well, thank you, everyone. I would say let's all turn our cameras on, and then we're ready for some Q&A. So in the chat, I noticed during your presentation, Dr. Shiva, we got a lot of questions about denture production with the Ackuretta. So I think the first question was about, like, first of all, what software you're going to use for that, CAD software, and, you know, what can you do in exocad that will help you along this way? And then I think some of the questions were also about printing. So which resin would you be using? You know, what do you have to look out for? So if you guys can share some insight onto this process, let us know.
Yeah, as the design is concerned, I use exocad complete denture module to work on it. It is quite a good workflow we have, and a lot of teeth set the teeth sets have been added. There are, of course, some teeth sets. You know what? There are ways of printing it, or the ways of designing it. You want it to print with a monoblock, or you want to print the teeth and put the base, or mill the teeth, mill the base. There are a lot of things. But you know what? I have a couple of resins which I use, and mostly I use the Curo denture resin here, which is my favorite is a dark pink. I got a, you know what? I like the color which comes out of it. And of course, there is one Dr. Priyam, who's my good friend, has asked a question. I've answered him. But he asked a question: why is it looking opaque? The denture base looks opaque after you do it. It is a lot to do with the thickness of the denture. Plus, you will have to do a good post curing, Dr. Priyam. What I mean by post curing is that it requires a curing, because see, what happens is when we are printing denture bases, it is about 2 mm or 1.8 millimeters of thickness of the resin. And as we all know, when we are doing our curing, or when we are doing our printing, it is only partially cured. It is not completely cured. So when we put it into our curing ovens, the intensity of the UV light and things like that, normally it is around 15 to 20 minutes is what you cure on each side. It depends on the curing unit you are using. I know you are using curing, but depending on the curing unit and the resin, you can look into it, and you can do a little bit of variations into it. And if you do a good curing and polish, it takes a good polish also, then you can work on it. So that is what is the way denture-based resin is done. And some people have asked me, how do you glue the teeth to the denture base? I use the same resin, the same pink resin which I use it. So I put it across, then remove the flash. You know what? How we remove the flash? Take it out, take a cotton or a small applicator. Usually I like the applicator which we use it to apply the primer onto the teeth. I take the applicator, remove the resin out, and then put it in the curing oven for 20 minutes or 25 minutes so that I get a complete cure on the base. And so far, to be honest, I've done maybe 25, 30, 40 dentures, and I've not had a debond of the teeth to be done. And of course, the fit of it, and other people are asking for the fit of it. I think you need to set when you're working on exocad, you need to go and set the parameters in exocad on the base depth. See, there is a depth, they call it as a pocket depth. So you will have to go change your settings based on the printer and based on the resin what you're using. It takes, once or twice, you'll have to do a little bit of adjustment. It's like, when we initially, Manish will tell me, Manish will also agree with me that when we buy a milling machine, a couple of times we just do a couple of crowns to know whether which is a good fit of the crown, which is a bad fit of the crown, how much of spacer is there. The same way, when you're working with the resin and the software, the exocad software is that way. That is one of the reasons why I like exocad software, is because it gives me the flexibility of to do what I want. I can send my parameters, I can set my parameters, and now exocad is also including all the you choose as 3D printing in your workflow, and then you can select your printer. So there is already a default settings which are there inside your printer. So like, for example, Sol is all been incorporated into it. So you can just go, initial days, you can just go select it and then you work on it. Okay, I think I've answered.
Yeah.
Yeah, I think about the denture also, what you said, the settings can be done in exocad, but the doctor who reached out to us has a different software. So I think he'll have to find out the settings in that software.
Yes, yes.
I think also there is a possibility to do it in our 3D software, Alpha 3D software. Also, you can change the settings a bit to get the fittings correct. So I think that is something that you will have to try.
I guess it's a trial and error method which you have to follow.
Unless and until the settings are available inside the software, this will have to be done by trial and error. Yes.
All right. Thank you for the in-depth answer here. I think one last question that someone asked was, what's the printing time for dentures? And I can already tell you that's going to be a little bit longer than you would first expect because of the way you have to orient that in Alpha 3D. So dentures can take somewhere, I would say it's probably like 3 hours with the sole. How long does it usually take you, Dr. Shiva? I think that's somewhere.
You know what, if I'm using my standard mode and do it, roughly around 1.5 hours to 2 hours it takes to print, depending on what orientation I'm placing. See, if I'm giving my orientation at around a little bit less than 65 degrees, it becomes faster. And sometimes, you know what, if I want to do just a monolithic denture, I normally keep it a little less so that I want it to be a little faster. I agree with you that time takes time.
Yeah, monolithic is, I think, actually a really good way to go. And recently we've seen a lot more doctors and technicians printing monolithic because then you just, put on the staining at the bottom and then that looks great. Okay, we had another question about, does the quality of the printer affect the post-processing time? I think that question is a bit vague. I would say the quality of the printer affects the quality of your print. That's probably what I would say, but I would give that over to Manish, Dr. Shiva.
Yeah, the quality of the printer will definitely, yes.
Yeah, for me, you know what? For me, you know what? I'm a little bit confused with that question. What the doctor is trying to ask me. If he's talking about the quality of another printer and post-processing, you know what? It depends on the light what he's using. See, he'll have to go into the printer, whatever printer he's using. He has to understand what is the light quality of the printer, and based on that, yes, post-processing changes. If your light quality is not great and it is not the power, as I told you about the active light engine and just the normal one. If you have an active light engine, at least 60% of your curing is done on in your printer. Then you can, your post-processing time comes down. But if your the quality of your printer is not great, especially in denture bases, because you should understand that denture bases, as I've already mentioned, you are thicker compared to when I'm doing my crown or when I'm doing my bridge. Crown and bridge, I'm just looking at 1 mm of thickness. When I'm looking at a denture base, I'm looking at least 1.8 or 2 mm or sometimes 2.2 mm of my denture base. So it takes a little longer time for it to cure. So post-processing changes definitely depending on the light what you have used.
Yeah, so I will add to Dr. Shiva here is that not only the quality of the printer, but quality of the curing device also is very important, because that is what is doing the final curing. And based on the final curing, the post-processing, like the polishing and finishing of the teeth or the dentures, will definitely be different. So the post-curing device is equally important in this case, I would say.
All right. I think one interesting question is, what does open access and closed access software mean? So that is a question for Dr. Meghana. I think that let's talk about this real quick.
Yeah, so I mean, open access is if the software is available for everyone for free to use. And it's very different from open sourced, which I am not too sure whether the question is directed towards open source or open access. Because open access would mean it is accessible to everyone for free to use, how many ever modules or however they want. But open sourced, if that is what the person is asking, would mean that the code of the software would be available for modification. So I'm not entirely sure what the question was, which of these two.
Let's answer it broadly. I would say let's discuss both cases.
Okay. So open access would mean that the software is available to use for free. It would be available on any platform that the end user could access and use it the way he wants. Open source would mean that the code of the software is available for the end user to kind of modify and change and use the way that he or she would want to. So broadly, that's the difference between the two.
Okay, with exocad, we are luckily looking at a very dental specific software. Yes, that is, obviously there's a lot of work put into this software. And that's why we are emphasizing the fact that you should absolutely be buying from a local reseller, and also be sure to get some training with that software.
For sure. Yeah. So it is a software that you can actually customize based on what you actually want to use it for. So it is modular. So if you would like to use it for basic indications, you can buy modules or purchase modules that allows you to do that. And in case you want to use it for a wider range of indications, of course, there are modules that you can use for that. So it would really depend on what you want, and which is why we have trained resellers. We have a good support system. So it's always better to be in contact with them and decide what's the best software for you.
Mm-hmm. And right here, we have 2 exocad trainers on this call. So in India, there is no lack of them, and you can reach out.
Absolutely not.
Yeah, sorry. We have another question about, and I'll combine the two. It's, any printer is open to use with any resin or closed system. So there's a lot of printers out there that are not an open system. That means they are limited in the types of resins that are available for them. The Ackuretta systems are actually semi-open. This means we at Ackuretta, together with the resin manufacturers, calibrate and validate those resins for you. So that means you already have the parameters in the printer. That means you do not have to do any calibration yourself, which is very important to ensuring the biocompatibility and mechanical stability of each printed part. But we're actually going one step further. We don't just calibrate it for the printer, but also for the entire workflow. That means even the wash station and the curing unit, it will also be validated for that. So it means it is a semi-open system because you cannot use any resin, but you can pick from over 150 resin profiles to work with this printer. Yeah, and I think that is really a key thing to say. We are semi-open, and this list is always growing because we are putting a lot of work into it. Now, the other question was, which resin is recommended for permanent crown? And I think here we can already say that there's multiple different resins that are available for permanent crowns. Manish, Dr. Shiva, what is your recommendation for permanent crowns?
Right now, since I have the Begos Versio Smile, I'm using it. I have not, personally, I have not used any other resins, but I've seen in the market that there are a few resins already available in the market.
Yeah, I have also had experience with the Bego resin, and it has been absolutely fantastic. So no second thoughts on that. And adding to Julia, the Ackuretta printer is actually fully open, not semi-open because yeah. But the validated resins are, I would say, for everyone to use, and so that you don't have to waste time, effort, and money into creating your own validations.
Yeah, when I say validation, it's the key thing that we would like to emphasize, the fact that there's 150 resin profiles to use for everyone.
Yeah.
we do not really encourage the self-calibration of any resins because we cannot attest and we cannot assure that those resins will actually lead to biocompatible and mechanically stable results. So please keep looking at the list that we do have because there's plenty available. Okay, let me see if we have another question that we can answer before we wrap up today. We have one question. Is the sole printer useful? Okay, is the sole printer accurate for EMEX crowns? I mean, are there no problems after casting? So if you're using a cast resin here.
So if you're using the Ackuretta cast resin, there is no problem with the EMEX crowns.
Okay, that was a quick answer. And I will just type in here, no problem. Okay, great. Did you guys have anything else that you wanted to mention, to bring up again? Let me re-emphasize again, everyone is very welcome to join on November 26th for the workshop with Dr. Shiva as our lecturer. I will send again the information. You can either sign up through the link or directly with Manish. He's shared his email address in the chat as well, and I'll reshare it here as well. So be sure if you want to learn more, stop on over. Be sure to sign up in advance because we do need to know that you're coming in beforehand.
Yeah, this is going to be a limited seat hands-on, so I think it's on first come first basis. So I would tell everyone to rush.
Yes, I actually have already received, Manish, a couple of registrations just during this course. So we're very excited to see quite a few here, quite a few there. I would say, let me already start by thanking so much Dr. Meghana, I'm sorry, for attending and here for answering our questions. It's really been great to organize this with you guys. Dr. Shiva, I don't think I can thank you enough. You've always been a great mentor, advisor, and teacher for all of us here at Ackuretta and to all of our customers as well. And then, of course, Dental Ceramists, Manish, thank you so much for your time. And we're looking forward to working with you guys at the workshop soon. So thank you so much, everyone. Dr. Shiva, do you have any final words for the attendees? What do you recommend people when they want to start with 3D printing or digital workflows in general? What's your words of wisdom?
I would say that you make your research, don't rush into it. Don't just buy, just because a particular a product is at X price or a Y price, don't just dump into it. Because one thing you should understand is that, you know what, if you're going in for an economical product, I would not say it's not cheap, I would say economical product into it and the pricing goes down onto it. The only thing is you will have to validate everything. The whole workflow, you will have to do everything. Here, you pay a small premium to it, but what you are doing is you are giving you are getting a validated protocol, a validated workflow where you're going to waste, you're not going to waste too much of time adapting this technology. Otherwise, believe me, it will become a frustrating place, especially 3D printing. If you start a 3D printing without a validated workflow, I'm sure, I know a lot of people inside this group only who's attending. I see a lot of names who are good friends of mine. I see that they all have gone through a lot of, you know, I would, if I don't want to use that word, it's a frustrating experience when I'm doing 3D printing.
A lot of cost in wasted resin and time.
Yeah, that is what I would like to say, that you get into this and then, you know what, you can get, but sure, don't wait. Tomorrow the cost is going to go down. Because tomorrow, if the cost goes down, at the same time, you have another 100 people working for it on the same product. So you're going to miss the bus. So the earlier, the better. The early adapters are always the best adapters.
Okay.
You know what? It says, no, the early bird gets the prey.
Yeah.
So it's the same. So because see, we've been, me, Manish and Meghna to a certain extent have all been in the early risers in the digital technology. So we are seeing the benefits of it, and we personally I've experienced a lot of benefits out of its technology going through it, and I'm sure there are a lot more to come. It's not of resins, a lot more things to come into this picture, and I'm sure it's an exciting era for dentistry. I would say, I would sum up as exciting era for dentistry.
Thank you.
I would totally agree with you and second that, Dr. Shiva. And I also think that India as a country is so advanced when it comes to adopting technology soon. So if you look at a lot of people, the awareness, the number of dentists, the number of lab technicians are actually adopting this right now. Really exciting times, and I'm very proud about the way our dental community is growing here.
Great. Thank you so much for your... Yeah, Manish, did you want to say your insight on this?
Yeah, I think Dr. Shiva and Meghna has clearly stated what is need of the hour. And I am with hands on the ground. I am in touch with these laboratories and many of the dentists whom we support and service. So I know how deep, how fast the technology is catching up. I have been to remote places where it is very difficult to even reach by a car, and they are investing into softwares and CAD/CAM machines. So I think it is going places, and if people in such remote places can think about it with towns like only 20,000 people, I think the people in the cities should wake up and pick it up before they lose the bus, I would say.
All right. Then thank you again to everyone. Unfortunately, we will not be taking the last question, but you feel free to send us an email about it, or send it to Manish or to us at Ackuretta directly. Thanks again to everyone for being here. Don't forget to sign up for the event. For those of you who joined in late, you guys can watch the recording right here, right after we finish. So again, thanks to all our attendees and especially to our guest speakers here. It's been really great to have you, and I know I will see you all very soon. So thank you all.
See you, Julia. Bye. Thank you, Julia. It's been a pleasure.
Bye-bye. Bye.
Thank you, Meghna. Thank you, Manish. Thank you. Bye-bye.
Bye. Thank you, sir. Bye.